I hope you are excited to hear some architecture stuff. We have Toby Henderson here. He's currently an application architect at Huddle, previously worked in the finance sector as a technical architect, developer, and operations manager for over 20 years. He also enjoys dancing, yoga, namaste, coffee, food, don't we all, and a nice glass of whiskey, which is exactly what I'm going to do this evening. Let's now hear big microservices, small team, a painful story. Toby?
Thank you very much. Hi everyone, welcome. Thank you for coming to my talk. This is a journey my company has been going through for the last couple of years, three years. So it's the painful part of microservices. About 9 years ago, we started a journey which before the term microservices was coined, back in the day we used to call it guerrilla SOA. We started this journey, which I'm going to take you through just to set up some context. And yeah, but the painful part is what I'll talk to about halfway through the talk. So let's get started. Who am I? Well, I've just had an introduction anyway, but if you want to find me on the internet, Holy T-shirt on Twitter. I'm going to do a little plug here for an open source project that I work on with Ian Cooper. It's actually at the heart of the Huddle product. It's basically a messaging framework for C# and .NET products. So if you're using something like Mediator and then you started to use Mass Transit, you probably want to come have a look at Brighter because that does everything in the box for you. Okay, one of the things, so I'm going to talk about Conway's law here, which you can read the description there. But basically, how your communication and your teams are set up is kind of what you're going to build. Your company structure, your communication structures are going to influence how you build your software. So originally, our product was some founders. They went out, they got some funding, they got a little bit of funding, they had this idea. They went out to a company and they said, can you build this product? They got a couple of devs and they built a nice structured monolith. This is 15 years ago. So it was an ASP.NET web application. It had a couple of capabilities in it. They were well defined because that's what they thought of it right at the beginning. They had a small team working on it. It was just a ASP.NET web app, a database, and a team. It was really easy to deploy. No problems. Life was good. They were solving problems. They got some more funding. They sold to customers. They got more funding. They got more interest. But the customers came back and said, I really like what you built here. Can we have some more features, some more capabilities of your product? So what happens? You throw some more in. And you go, well, that's working well. You get more feedback. You decide to slap on some more features. And your product starts looking like this. You've got tied, you've gone past ASP.NET is dead now. MVC is a new way to do it. Your code base is a bit messy. So what you do is you tack on a piece of MVC on the side because that's what all the cool kids are doing at the moment. And you hear about this thing of like APIs are cool, so you've got to add an API on top of this as well. And now you've got to increase the team because you need more people to build more features. And now it's getting a little messy. You're getting what we call nowadays, a spaghetti code base, a monolithic application. And you want to add more people and do more things because you're getting more money, more customers, you want to drive forward. So what do? You add more. Now you got a couple more APIs, you got a whole lot of different capabilities that your product is capable of. You got some schedulers that run in the background, you got some back-end services that run and do some work for you. You're not just speaking to SQL, you're speaking to Redis. Now you have 4 teams working on the same code base. And what happens? You get to a point where you can't go any faster. You're actually going slower than you used to go before. Testing takes forever. You can only cut a release once a month. Your testing cycle to get that release out is 2 weeks long. If you add more people to the team, all they do is spend days fighting with each other, arguing about commits, who's going to go in first. If you check in a feature, unit test, early days of unit testing back then, you may get your feedback from your UI test about 3 days later. So you actually don't know who's broken what. It's quite a mess. So you've got these separate teams, but you've got a single code base, a single repository, and everyone's playing in the same repository. It's, because you're a startup, this is how startups should start. You basically create a ton of features, a ton of capabilities, you throw everything against the wall, see what sticks, see what customers like, and you move forward. But, after a period of time, you should look back and say, maybe we should rewrite this prototype that we've been building on for the last 5-6 years. It might be a good idea. Everyone had this problem. Twitter had it. If you remember the fail whale, it kept falling over all the time. I think they've rewritten Twitter twice. Facebook have done it, but then they just wrote their own compiler to help them get through some of the pain. So you get to a point where you have to get some help. So you go out, you find some people who know how to help fix you the problem. So what you look at is say, what does our product do? So you get some people in, they have a look at the whole product, and they say, well, you've got all these different capabilities. And I'm talking about what you call business capabilities. These are complete units of functionality or groups of pieces of functionality that do a similar thing. And you say, well, which ones are these important? Because we shouldn't be doing probably all of them now. It's been 5, 6, 7, probably 7 years now. We know which ones are making us money, which ones are working. So you do a bit of analysis. You say, well, these ones are our core ones. These are the ones you have to do. Kind of like identity. That you have to do it. It's not glorious. But it has to do all the things that identity does. Otherwise, customers aren't going to onboard with you. You should probably remove those ones because they're useless, and potentially, maybe your mobile apps or something like that, maybe you should just outsource that to someone else because you just don't have enough people at the moment. That's just all potential things. But after looking at your capabilities, you kind of recognize something from the structure back here. You kind of go, well, there's an API, there's a service, there's some schedulers, there's a database. Maybe what we should do is kind of like do something like this. We have a capability, it has an API, there's some services, some CLI tooling that go with it, a scheduler. It talks to a database, a key value store, some type of search infrastructure. And that capability, what we're going to do is align it with a team. So this is the original idea of microservices. If you look back at James Lewis's, they talk about business capabilities, and he talks about business capabilities, not about single services like an API or a service as being a microservice. And you also don't want to be at the other end in a monolith. So this is what I kind of term, Goldilocks microservices. Not too big, not too small, just right. But generally, what you want to do is with your microservice is if you're talking to the same schema, and you have to be deployed together, then you are within the same microservice boundary or business capability as well. So, you plan this. You say this is what we're going to go forward for. You look at that horrible code base before. You find all the code. You cut it out and move it into this new service. You tidy it up, clean it up. And you do that, and you rinse and repeat. And you end up with a nice, wonderful, structured, one team, one capability, completely independent, there's clear boundaries. The teams aren't fighting over this in the same repository. Independently tested, completely. You don't have to fire up the whole thing. You can just test your BC only. This is, you're living the dream here. This is Conway's law in action. Teams and communication are separated, and they work on their own things. There's some advantages of microservices. You can have these can now, evolve completely independent of each other. They can evolve at different speeds. You can even use different databases if you want to. They can also use multiple languages, and then we get to some of the benefits of microservices. So the first one that we were looking at was we wanted to better scale the teams. We had all these teams, but they couldn't move fast enough, so you want to better scale the teams. And you also want to scale the code. One of the nice things about microservices is every single one of those can be independently scaled without affecting the other ones. You don't have to, if you had a monolith, you have to scale pretty much the whole monolith. Where this one, you can just scale the part that's struggling. You don't have to scale the whole thing. Within that microservice, the team can just focus on that one business capability. A lot of people say, well, why can't they focus on the whole product? When you get to focus on just the one capability, you get to understand that domain in its entirety. You also know how to take it forward. You also have ideas about improving it. This doesn't happen if you just kind of visit a domain, have a look at it, get some understanding of it, make some changes to it, and off you go to the next one. You won't get any maturity, you won't get any growth, and probably the only person who's giving any value and changes of direction of that is going to be the product manager who's focusing on it. But as a developer, you're looking at the data, you're understanding the data, you've got ideas too. So one of the things we noticed when we did microservices is the team, I think we bought, in our product, we built more features into product from the developers than actually were delivered by our product team. Product gave product features, but kind of these extra special parts in our product that customers really love actually came from our developers. You get all the nice things, the independently deployable, they can evolve at different speeds, different databases, and then you have, what really does help is having cross-functional teams. So each one of the teams there, they had developers, we had QAs inside of them, we had a product manager for each of the business capabilities, and then we had UX and UI people working there as well. And this is basically what I call microservices. So, we're living the dream. Why am I giving this talk? Why aren't I selling that vision? So what happened? We got sold. So every startup's dream, I joined just before the second round of funding. We did 4 rounds of funding. It was like, yay, loads of money, no money, loads of money, no money, loads of money. We're gonna be £3 billion, pound company. But what happened was our major shareholder decided to pull out, and there was a thing called a drag-along clause, which you probably should learn about if you're in a startup world. And basically what that means is your major shareholder can go, well, I'm out of here and I'm going to cash out as cheap as possible. I'm just going to sell it to someone because I can't be bothered. And that forces everyone else to sell at the same price. The low, basically it's a fire sale. So yeah, we got bought by private equity. It's actually not as bad as you think. It was bad, but it wasn't bad. And unfortunately, because we were no longer a startup and now we had to run off our own balance sheet, is a lot of people didn't enjoy that environment. They didn't want to work for a normal company anymore. So in about 6 months, we lost 80% of the development team. So we had this. This was problematic. How do we have just a couple of people run this whole thing that was designed to scale? What we were trying to do is we got to a point where we got everything, and we were planning for a future where there'll be more teams, more microservices. But that didn't happen. We never thought about what will happen if this happens. Never thought about it. Now we've only got a handful of people left. We were very lucky that the system was very stable. One of the things that we did do when we created microservices is the team was responsible for, building the code, getting that code through all the environments and putting it live, and then looking after that code in the live and observing that code in the live. So, they didn't want to get woken up at 3 a.m. So they basically wrote really stable code that they only had to look after in kind of office hours. Some of the people had never worked on any other sections. They had no idea what other, they knew about them, they'd use them in the product, but they actually had, how did that code look in the background? They had no idea. You have to go and beg the company and say, we really need some more people here because our system just won't work without this. This is kind of like you've gone to, you follow Conway's law, and now you've been forced into this position where you're not following Conway's law anymore. You're basically in a very tight spot. If you saw before, we had like a big mess of code, a monolith. So we actually planned around Conway's law. We actually thought about it, we talked about it, and that's what we came up and end up with microservices, as you do, and now we're kind of going back the reverse direction. Accepting, it's hard to reverse this back to monolith. You can do it, but this is a lot of code. Getting to the point where here, it was 7 years of work. Because at the same time as creating microservices, we didn't just stop. We actually had to build features and new features for all our customers. We're being given money by investors, and they say, hey, you need to build this X, Y, and Z as well into your product. So we're building tons of new features at the same time as delivering. In the back end is completely changing the architecture of our code base and how our code is deployed into live environments. I describe it as, basically you take off as a Cessna and you rebuild this plane in the sky while the passengers don't really notice, and you're landing as a jumbo jet. So at this point, all you can pretty much do is just keep it running. You can probably fix some bugs, do a little bit of patching. The people that kind of know their one capability can keep on working in that. We tried some things like we hired a couple of more people. We started hiring more people, but we got a whole bunch of people who come in, had never seen microservices before. We're just like, wow, there's so much stuff. And now they had to learn not just one. So before you would come into one of these microservices and join this team, you only cared about the one little world. You only cared about that one domain. And then you learned all the kind of bits around it, and then after a while you realize, I actually can't cut and paste. So when I jump around, the only thing I have to learn in the new world is the domain. It's quite nice. So you end up saying, well, I can't assign people across these teams. I tried to, but I put seniors in charge of each one. But it doesn't really work because as like the person who does know everything, I'm just stretched thin trying to teach individuals about their one place that they're looking after constantly. So we just folded down to one team. Because then what we did is then we said what we're going to do is we'll basically focus on a capability for a period of time and then move on to the next one. And then the whole team will do it together. That means I can upskill the whole team at the same time as we jump and go through them. This was a little harder for us because we couldn't just choose to work on different capabilities where we work in a very compliance-heavy environment, and as we get scanned once a month for vulnerabilities, and as soon as a vulnerability or they find something in it, if it's a high, we have 30 days to fix it. If it's medium, we have 60, and then we've got 90 days. So we get deadlines of having to fix stuff like pretty quickly. So it means a lot of jumping around, but we have no choice. Sorry, just gonna have a drink of water. But as you can see here, it's like, well, how do you survive? What are the benefits of microservices now? These were the benefits that I put on the slide earlier. So, scale teams. Well, that's not happening. We only got a single team now. So that's a single team. We used to have, each team used to run their own process. So some people were running like Kanban boards. Some people were running their own hybrid version of how they did anything. Some people were just running, cards on a board. So we had to fold down to just one board for everything. Within that board, we actually ended up dividing it into multiple lines, so like swim lanes in Kanban. And mainly what they were are product features that we can work on, and support. My team has to do support. We don't have anyone else to do it. But I can tell you, when you're supporting the entire product, it can be very demoralizing. So what we did is we had a rota. So we didn't just say, okay, you're working on support. So we had like we ended up at a 2-week rota. What you don't want to do is kind of demoralize and burn out anyone in your team. So if you ever end up in this situation, you're probably going to assign about 2 people to your support thing. Probably only keep it in 2 weeks is just like the maximum we found, that people were just getting, it's like, this is enough, and they'll come off and they'll be like, oh, phew. But you also want to try and push your product and say, look, we can't focus on like the whole thing. We can only focus on one piece at a time. Luckily, we had some quite nice product people, and we managed to add new features to the product while keeping it running and fix all the bugs at the same time with a very small handful of people. And just continuously remind the business, hire more people, please, just beg. Because if anything goes wrong, they can't come and blame you. Scale the code. Yeah, that was still pretty good in this world, but the problem is it's a lot to manage. The one thing that really helped is having a really robust deployment pipeline and being able to roll back very quickly. You just don't know how good, how helpful that is. We use it, I can't be more grateful for Octopus Deploy. It just is a click of a button. Your code is out there. I've got some issues, hit another button, and the previous version is back out there. You've got to accept that you're going to lose some maturity. So before when we're in microservices, the teams had become very into kind of matured into being very observable of their capabilities in the wild. We had around the office, we had screens. Each team had like multiple screens with graphs all over them. And sometimes you just be kind of like at the corner of their eye, you'll see a graph peaking, and then someone will be like, oh, something's happening with our part of the system. And they'll be straight in there and fixing it. You've got to just work out that you can't use, you're reactive now. There are too few people to kind of be observable. But you have all this observability set up. So what do? You basically have to set thresholds on that observability and a whole bunch of alerts. Hopefully you've done that before. But what you'll do is you'll probably do a lot more now. So you probably won't be looking at that observability on a daily. You won't be looking at the dashboards, constantly. But what you will be doing is hopefully they'll be pushing stuff to you and alerting you and letting you know that stuff is happening before you get phone calls from the customers. One thing that also helps is you've got a lot of code to look after, have automated security checks, so run stuff like Sonar on your code. Use third-party products like Sync or White Source, or I think White Source has got an open source version called Renovate. How do you keep all this code up to date? Because, compliant environment, once or twice, 2 or 3 times a year, we come inside and people actually look at the code base and go, well, you're using these third-party libraries and they have vulnerabilities in them. That's not a good thing. Focus on single business capability and generally a single domain. Yeah, that was good and it was bad. Bad being now my team had to learn everything. The good thing is when we were working with product and we forced them and say, hey, we can only work on one of these at a time, we got to work on it and we just got to kind of work in that little world. Generally, the support person was spread out across everything, but for that period of time where we were working, 4 or 8 weeks, you just played in that same place over and you got to learn the world very well. But the one thing you've got to accept that people aren't going to improve anything. What they're going to do is they will kind of load up this domain into their mind to the point where they can develop and work in that world. And then once that's finished, and probably maybe improve it a little bit, but the improvements are going to be very slow. And then, you've got to drop it all out and then move to the next domain. And you've got to also discuss with products and say, which parts of this, which capabilities do we just put on the shelf? They are good enough because they work. What we do is keep them up to date, and that's basically all we can do. Independently deployable. This is still really useful, even if you're a small team. Being able to just, work on some code, push it through your CI system, and then be able to just deploy that one piece of code is much easier than having to maintain a large monolith. It still helps you a lot. It only really works if you do have, a mature deployment system. One of the things that we did find is every one of the teams that started their build scripts, the actual deployment scripts that were executed by the deployment system were slightly different. So if you actually had to make a change to them, it was very, very difficult. One thing I'd say is exercise your deploy pipelines regularly. We had something like 16, 17. And what you're doing is the product will mainly focus on kind of your 3 or 4 main features, but the other ones will be sitting there and won't get nothing will go through them for months. So that's why I say use things like the automatic update software. What that does is it will force a build, it'll create a deployment and have a deployment ready to go through. We went from most of our infrastructure being on-prem to in the cloud. And basically our build agents all completely changed. So when we actually went to push stuff out, a lot of stuff was broken. I mean, it was quite quick to fix, but it caught us by surprise. Having a mature CI pipelines really, really helps. One thing again is look at all of them, because all the capabilities were now done by individual teams. They were growing at different rates. People had different ideas. Some of those deployment pipelines were quite different from each other. So one thing is make them all the same, or as much as possible. And again, exercise your CI regularly. There's nothing worse when you've got to make a change to a product because of a bug or an issue, and it hasn't been touched for like 8 months, and you push it out and the code is red. You get a building, you push it to do all the acceptance tests, everything's red because something's changed, passwords are gone, your whole infrastructure is using a different domain now. These are examples of real things. The evolve at different speeds, that was very nice in the microservice world because we didn't have to force teams to go through, don't do everything the same at the same time. That's great for those teams, but now everyone had gone. The differences between some of these were very big. We also had, there's no one there left. Some entire teams walked out. We lost the whole team within like a month. They didn't leave much documentation behind. We had lots of plans. Our whole plan was, from, ASP.NET, MVC, move that to microservices with APIs, with a SPA application at the front. Moving off on-prem into the cloud, then from the cloud into Docker and microservices, and maybe then Kubernetes or some type of container management framework in the future. That was kind of like our path. But each one of these code bases were at different levels. I'll show you a bit later like how we kind of look at this and across our stack. Things are like, you go into one repository, one of the capabilities, and they use a make file. The other we still had some rake lying around. We had sake and fake, and it was like just choose one. So we actually spent a lot of time as a team just making sure that with C#, so we use cake across everything and make sure the cake scripts are all similar. It just makes everyone's life easier. Then also everyone was using a different logging framework depending on like their maturity. Luckily the database access was pretty much the same with everyone. Some people were using different web frameworks. And we'd also taken an approach when we were moving from the monolith to microservices is not to remove any of the old code. What we're going to do is say, let's move all these microservices out and just leave that old code to just die. And then hopefully we just won't use it anymore. That did not happen. And I wish if I could go back in time and change one thing, it would be to go back and delete all that old code. We still have some of that old code living in production. And it's very difficult when we have a lot of new people joining our team or new people on the team is they don't know if it's used or not. And there's a lot of it. So I know we used to take this, we took an attitude of don't delete the old code, just move forward with the new code. Looking back, I would change that now. I know it's a waste of people's time. It takes time to go in and delete all that code, but the amount of developer satisfaction at removing that legacy code gives people, and now not having to, I wish didn't have to deal with it today. I wish it was gone. So if you are on that journey, I recommend just removing that old code, please. Multiple languages. This is quite painful. We had mainly C#, we also Python and F#, also in JavaScript as well. So we have some Node code as well. JavaScript's not too bad because pretty much everyone needs to know JavaScript. F#, we had like 6, 7 people who used to be interested in being able to write F# code. After everyone left, we had no one except probably me who knows a little bit of functional programming. That's not a good thing. Python, pretty much again, only myself who know, and the QAs. So the only developers who could actually help us with our capabilities that were written in Python was actually our QA team, because our QA team write all their tests in Python. So they actually were our developers. They were like our best developers. We had other languages like Objective-C and Java to deal with as well. So when you come to this, you have to make a hard decision and say, yeah, F#'s a wonderful language, but my team only know how to do C#. So what you have to do is basically turn all that code back into C#. Python code, no one is, it's a nice code to work with, but I swear, working in Python environments and making sure you're getting your local dependencies correct I find it personally a nightmare. So, yep, turn that back to C#. Single language is so much easier to deal with a very small team. Independently testable, again, this is still really great. When you are working on something and you're working with your testers, they only have to test one capability at a time. That's easy for them, it's easy for you. Life's good. And that fits in with independent CI, independently deployable, and having independent environments for each of the kind of capabilities helps as well. So we have, you work on the code, a repository for a capability, you push your code, we have a build pipeline for that capability, which then deploys out to an environment for that capability where you run the acceptance test against that environment. We also have, in between all of that, so after you build the code, we have code checks, sonar scans, old libraries, before you even get out your code, and then deployment packages are created, you push them through to an integrated environment, then to staging, then to production. But the independent testing really helps, especially when you get new testers join your team. They only have to learn about the one thing that they're working on. Cross-functional teams. This is kind of okay. We lost a lot of people, so we were still a cross-functional team, but we were also, just not cross-functional, we were cross-system as well. So the problem is we had to take on a ton of responsibility from all the other roles that are left. And you just end up being stretched. There's also just too much to think about. It's very overwhelming. And the only thing I can say again is if you want to get anything done, you want to move forward slightly, is you have to focus on one capability at a time. That's all you can really do if you want to move forward. So I talked about earlier about how do you know the state of your system? You inherit this landscape of all this code. How do you map this code base after evolving at different speeds? We've got maps like, this is the layout of, this is these services and these business capabilities and that type of map. But I want to see is this code framework for, what version of the framework is it at? Because I need to know, because I need to upgrade it. How am I going to get the stuff to .NET Core so I can put it in a container, so I can then do Docker so I can get out there and so we put a spreadsheet together. So as you can see there, we are tracking for each of these are the microservices, so you can tell how many microservices we have it. And then which ones are currently Cake, which ones aren't, which ones are using the new .NET project format. And then we're tracking which ones is where we're starting to use environmental variables for, because if you've got environmental variables, then it's easier, then you can put in a Docker container. And because our TechOps team weren't quite ready for Docker, but they could do Linux, so what we do is we'll make sure that we could run it in a supervisor as well. And then we've got some other things here, like what were the current states. So this is about 3 years ago, I think. So you can see that we had a lot of work to do. A lot of red there. And then some of our major libraries, like what version of Bright are we on? Current version 8. That's quite behind us. And we iterated on the spreadsheet. The team got joined in. It took quite a while. We still, we're teaching the team. It took like about a year to 2 years before the team felt confident to start going in and moving the architecture forward to something that would be easier for us, that we wanted to work on as developers. The kind of first year after everyone left and we hired a new team, it was just, keeping the system running and teaching people. This is what it looks like now. So we've split it up. So you can see our mono repo is those kind of, I know they are independently deployable, but they are all deployable together because they all talk to the same database, unfortunately. Our core BCs are proper microservices. They have their own databases, completely independently deployable. You can see we got different web frameworks. We use Open Raster on one. We got Owen on one. ASP.NET Core. We track all sorts of things at the moment. So anything we need to track across all of these business capabilities. So even like things like the first one on here, it's the main branch. So converting from calling our master to main in GitHub. The other one is because we're a FedRAMP compliant company, we can only use other SaaS companies that are FedRAMP. So recently, GitHub.com has got FedRAMP Lite compliance. That means now we can put our code in FedRAMP in GitHub.com. Before we've had to host internally. You can see we pretty much finished the project. Everything's running on the new project format except for the really old legacy part of the system, which will die. We've got everything up to Net 4.7.2 ready to flip over to Net 6. All our libraries are up to date. That's taken years. All our downstream libraries, all our shared libraries between all of that, we had to make them all Net Standard 2. That takes a long while, so this helped track all of this. If we had multiple different ways of deploying databases, so we were moving just to using a database project, and we had some tooling built around that, which made it easy to deploy. So we were moving all the database projects into the different capabilities. You can see we did everything in Cake pretty much. Sonar, quality gate. This is the yes and no is not. The no is not that we're not checking it. It's just that we're not blocking a pipeline with it currently if it breaks. But we're still reporting on it. Libyears is a value that basically you can run using some tooling that calculates how old your third-party libraries are and gives you kind of a libyears. So the older your libyears is, the more out of date you are. It just kind of gives you a high-level view of the kind of state of the code base. And then for deployment, because we're still trying to move, we're looking for config by environment. That's still a lot of work for us to do if it's Docker ready. So currently internally, we're actually running on Docker. Some of the code is in Docker, and then we pull it out and we actually pull it out of the Docker container and then package it up to deploy onto Linux. And then we're not using supervisor anymore. We now move to systemd as well, so on Linux. So this is one place where the team, every time we come up with an idea and it's going to affect all of the code bases, we stick it on this sheet and we track the current state of this. I mean, before it was mainly red. Now it's more orangey greeny. It's actually quite a good feeling to go back and look at it over a period of time. And we look at this every couple of months. If one of us goes in and fix something, we always someone will say, "Have you filled in the spreadsheet?" it's becoming like a game to get everything green. We're also doing this for documentation. So we were recently bought by a new company. So the private equity flipped us after 3 years. And so we are being bought by another company. And one of the things is they've been getting some of their internal dev teams to join our dev team. And one of the things we noticed is kind of after time, the team, you kind of get used to the state of where everything is. You kind of like, oh yeah, it's this repository, the documentation is in this folder instead of that folder. And we realized it was a huge mess, especially when we're trying to help new people onboard new people now. So we decided to track our documentation. So we said, make sure that there is a purpose inside of the README, like what is the purpose of the capability? Has it got a nice overview with some like pictures of like how it looks? What is the message? Have the message contracts been documented? Is there a testing guide for the testers who are joining the team, and a deployment guide? Like how do you put this code live? And that is it. That's where we are today. We are surviving. We are still putting out new features, a lot slower. I can't say this has been easy, but yeah, I hope you enjoyed the talk. There is kind of some light at the end of the tunnel. We still have a lot of steps to climb. We're still trying to work out. We are getting more people on very, very slowly, and I'm still screaming to say, give me more people, because I need to get back to have more teams. Because this is hard work. A lot of microservices, small team, it is painful. It is a very painful process. Thank you very much.
Thank you very much, Toby. A round of applause. Now, if you have any questions here in the audience, it's time to raise your hands because we have quite of a chat on Pine. Your colleague Johnny jumped in to help out with those because they were just popping up, but I'm going to address some that aren't answered. Thomas asked at the beginning of your presentation, there is quite a fuzzy definition of what a business capability actually is. What is your definition?
My one is it's not what you think as a developer, it's what the business thinks. So as a business, you provide capabilities to your customers. Some of those capabilities are delivered by the product that you build. Some of them are delivered by just people. So you have a sales team, they provide a sales capability. You have a support team, they supply a support capability. You have an accounts team and reporting. Reporting could be, in our case, I'll be honest, we pull data out of the data warehouse, someone puts it into Excel spreadsheets, and if customers want anything more fancy than the basic reporting we do in the product. So some of the reporting is done by people, some of it is done by the product itself. But then we have a reporting BC, and that is one capability. And then within your product, our product is quite a large product. It does more than one thing, but it does them kind of, they are related. So we have documents and files and folders. They are one type of capability, so it's everything to do with that. We have a tasks capability, which is just about task management, these things are completely independent from each other. We also have people management. When people onboard into your product, you still want structures like company and accounts and sub-accounts and groups of people and teams. That is another capability. We have some what we call primary and secondary ones as well. So with some back-end capabilities which are kind of related to the primary ones, but they are slightly separate. But yeah, my one is the initial business capabilities. If you Google it, there's something called business capability mapping. It's an exercise you can do against your business, and there should be people from your engineering team, but there should be mainly business people, because you've got to say to what functions do we talk to our users with? What are these different capabilities that we talk? These capabilities that we provide to our customers. And then you'll work out what they are and which ones you want to deliver via your product and which ones you deliver just kind of manually or via Salesforce or by some third-party product. I don't know if that makes sense, hopefully.
Thank you. And one more question online. What are your tactics for deciding when and how much to work on new stuff versus fixing old stuff?
Well, that's quite easy for us. Fixing bugs, we have to. If they get bugs come in and we have to look at them and say, is this a high, medium, or low risk to our business? Or to, it could come through security. Security always comes first, so we have to drop everything. It doesn't matter if we're working on a major project, security comes first. A lot of our migration from our old code base to our new code base has been forced through by security, because we had a vulnerability that happened that was due to the old way we used to do something in a code base. So we actually took the opportunity to move some old code out of the code base into a new part of our system, because it was a security the potential of a security vulnerability happening or an incident happening was extraordinarily high. We had one incident. We spent the next couple of months fixing, moving that and moving forward. Beyond that, product will come to you. They're going to be swamped because they're struggling to pick and choose what they need to do all the time because they have so few resources, people. Sorry, I hate the word resources. I don't know why I said it. But yeah, you basically have to create a hit list of all the kind of things you want to work on. You got to try and prioritize them and just slowly work through them. You got to fight for that time. You got to remember that you are part of the system as well. Your product manager is not the person who knows everything. You need to fix things, and also you probably find that there are a lot of bugs in your system that are causing a ton of noise. So you get a whole lot of email or alerts and stuff like that, and it's just like someone's done a log error, and there really doesn't have to be one because you ignore it 90% of the time. So go in there and fix that code. Remove all that stuff so you can see. The problem is when you get tons, when you inherit the entire system, you get everyone's alerts. When it was spread out amongst everyone, people used to go, oh yeah, we can ignore that one and move on with their life. But now you're getting swamped by them. You've got to go in and try and fix them all out so you can kind of know what's really happening. So you can see the kind of the wood from the trees.
Thank you. That sums it up on questions on Pine. Anyone here would like to raise a question? Let me just run with the microphone.
It's David, isn't it? Shiny hair.
Thank you. One of the things that you mentioned halfway through was how diverse all these code bases were. You mentioned different logging frameworks here and there, different build scripts here and there.
Yep.
Do you think you would allow the teams to put that much diversity in a microservice architecture if you had your time again?
Oh, that's a hard one. So, at Huddle, the one thing we enforced across all the microservices, so we did enforce some things, was ports and adapters architecture. And using Brighter to help with that ports and adapters architecture. So the nice thing about any of the code bases, and I've had new people join our team, they know they can go into any of the code bases, and they know it's like, I don't know, let's say they go into the membership code base, and they're looking for something to do with create company. They'll go, well, there's probably a create company command. So they probably, you search for that. Oh, there it is. There's a create company command handler. They go to there, and they find that. That structure is pretty much throughout our entire code base. That means when you go there and you need to find stuff, you can find it. Logging is orthogonal concern.
You had to say it at some point, right?
Yeah, but part of me now wishes that we just made it all the same. It would be just easier.
It's one of those things I've been thinking about a lot recently, purely because I've seen this again, because it sounds like you optimize for development team freedom.
Yes.
In those projects, and it always feels like it makes a lot of sense. But every time, I'm just not really sure. Like, who cares how you log stuff? Just make it the same. It's not that important,
Yep. But, I'd say not young developers, but early mid developers, people really in their mid-career, they love to choose the latest framework, why are we using log4net, this Serialog, or the next thing, why we're just logging to console. I mean, they are right at the end of the day. You're just going to push it into something like Elk Stack or something like that, or New Relic's logging system or something like that. But when you need to make changes to it now, it's difficult. We have to go in and go, what are they using again? Oh, we can't do that. Migrating from one to the other is very difficult. When you move to .NET Core, it's a little easier because you have the iLog interface, which is common.
Because they force coherence there.
Well, because you can't choose anything else. You have no point. You have no choice. So it's kind of made for you. It is slightly easier there. We just never knew we were going to go backwards. I value developer freedom. You got to keep the devs happy. Let them play around. What we did make sure is we made sure the kind of architecture of the code, it was hexagonal. That was the same. That's the thing we focused on. I think that saved our butts.
Awesome. Thanks.
The other things, they're annoying, but not that hard to change.
All right, thank you. If there's no more questions, let's give a round of applause.
Thank you very much.
Toby.